Once again, my name is Chaitra Ramarao, and I'm a PM at Couchbase, typically in charge of database tooling and cross-data center replication. I'm using these terms given that you're all in 101 track, and you must have been familiarized by this by now. So the agenda typically for today is, it's a no-brainer. We all know when we are adopting any new database, data modeling is going to be a critical aspect, and probably one of the things which we have to get it right for being successful with the database. So, and today I think where the focus is going to be would be learning about how the data modeling differs for relational systems versus non-relational systems. And then we will also have a quick demo with our one of our newest partnerships that we have built for data modeling integration. Okay, so when we talk about NoSQL adoption, this is a cycle, and we all start. It begins with identifying the right application. So why do you say, if I ask you, like, why do you think Couchbase, why do you want to adapt Couchbase? What is your application about? You might come up with answers like, okay, I need to handle unstructured data. I have terabytes of data to store, and typical nature of big data applications like velocity, veracity. And yes, so I'm hoping that, okay, you're going to do the job and identify that adopting NoSQL or Couchbase is the right choice for you. Once you've made that choice, the very next step that you need to take for being successful with Couchbase would be modeling your data right. And we'll talk about that more, so I'm not going to emphasize about that right now. So for modeling your data, one other thing you need to be careful about is how do you plan to access your data? How do you expect your users to access your data? So Couchbase provides a number of ways to access your data. So are you going to be using it like a key value store where you're going to say, I'm just going to do set and get? Or are you going to say, I'm migrating from SQL, I'm migrating from relational world, so I'm like pretty comfortable with SQL, and I want to retain my skills and leverage them for better. So then you're going to say, okay, I'm going to adopt Nickel. Or you're going to say, okay, I'm just going to be the search guy and say you want to adapt full text search or anything. So you just have to be mindful of how you are going to access your data, and bear that in mind when you are modeling your data to adhere to those patterns. Once you've got these figured out, then it's all about installing the database, configuring them right for your application, sizing them and correctly, and then monitoring on an ongoing basis. And like I mentioned, the focus for today would be modeling your data for NoSQL systems. So, okay, I've been saying that, okay, data modeling. So what exactly is data modeling? This is something that I just describe it for myself. If I have to say data modeling in the simplest terms, I would say it is just the right organization of your data objects by bearing in mind your access patterns, so just to leverage your database to provide the best performance. So how do you really arrange your data objects, bearing in mind the access patterns of your data to ensure your database provides best performance? That is probably all what data modeling is about. Okay, so now we can spend a couple of minutes to see, like, how does the approach for data modeling differ from NoSQL to relational? So traditionally, when we were designing databases back in the day, what is data modeling? It was all about identifying the data objects and really understanding their relationships with one another, and then thinking about accurately really representing how these data models tie together. And that understanding of how those relationships and how those representations work, representations were actually laid out, was the foundation for a good database design. But when you come to the NoSQL world, it's more about how are users going to access our data. That will in turn dictate what kind of queries we might want to run on our databases to ensure best optimization. So this is where you can relate to how the traditional systems were schema on write, whereas the NoSQL systems are schema on read. So when you're modeling for NoSQL, bear in mind the application-specific access patterns, whereas in the traditional systems, you were always concerned about how am I going to design the database? How does my target database look like, and model the data for that? And one other thing that's worth highlighting is the normalization and denormalization aspects for migrating from relational to non-relational world. So back in the day, storage constraints were high, and having the right probably normalization was a lot emphasized because of the storage limitations back in the day, and also for access patterns, we typically preferred having them in different tables and doing joins. But NoSQL, I wouldn't say like it's completely denormalized, because ideally what we need would be a typical combination of normalized and denormalized data, but it relaxes normalization because it is more distributed databases. We have like redundancy and duplication and replication is something that we advocate. So this is where we relax normalization and emphasize denormalization a lot more when it comes to modeling for NoSQL. So now we've spoken about, okay, we want to do normalization, we want to access. So what is the data format in which Couchbase works? So JSON is the chosen typical data format for Couchbase. Why JSON? It's once again a no-brainer. It's like the most popular data interchange format for use today. It's lightweight, it's based on JavaScript, and it's typically human readable. It is easy for humans to read and write, and as well as for machines to parse and regenerate. And why did we choose JSON for Couchbase is because of some of the characteristics which we think offers great benefits to Couchbase, like schema flexibility. And it is definitely less verbose compared to our XML formats which we used. And it is also programming language independent. Like typically systems like Couchbase is written in so many other languages, but we still have one format, and it interacts with so many different applications, which is very helpful. And one thing which we highlight is, like, since in JSON it's all about objects, the data structures, and when we use the object-oriented languages like Java, there is a very less impedance mismatch, which also adds value to our performance. So I just thought we'll take a few examples of to demonstrate the characteristics of JSON, like for example, schema. Typically, in our relational systems, we always had like, okay, if we want to design the schema, let's say the first name and last name should be characters, and birth date should be a format for date. And if we want to populate the data in a table or a row, you can see that, okay, it's like, okay, first name should always be a name, last name should always be a name, and then birthday should be like a sequence of numbers or date that we have specified. Well, when you come to document databases like Couchbase, which use JSON, JSON is typically, like, it supports two object formats, like key and name and value pairs, and where names can be keys. So it's typically first name and last name. So where you can see that, okay, first name, last name, birth date, it's all stored in similar format. We do not really, it's like self-describing. We do not have, if you want to add some other field tomorrow, you can just do that, and you do not have to change your database schema just because you have more fields being added to your documents. Another characteristic why we love JSON is flexibility. So if you can just see in these two examples that I have taken, the same user type. It's like, let's say we are designing for the user called doc type as user. And you see that Shane Johnson, where they share, for the example of Shane Johnson, the billing and shipping addresses are different. And for the same user, for the type of user, now I have a different user called Brendan Bond, where the address is like, I have a completely different address, let's say, okay, some city called Half Moon Bay in state California, and I can just say, okay, shipping is same, and it works. So for the same user profile, we have different schemas. It provides, so JSON typically provides us that flexibility where you can use the same document type and have different fields and different types, and it's optional. There is nothing as to, okay, because you had so many fields in a document called for Shane Johnson, you necessarily need to have it for the other person. So it's self-describing and it is flexible. Okay, so what are some of the best practices if we have to propose some best? I just described until now that data modeling is going to be very crucial for success with any database system. So if we have to say give out something like, okay, what is the things that we have learned? What are the strategies that we propose or best practices? This is something that we have been practicing and which has worked well for us. So you can just validate your design based on some rules of thumb, like, okay, should the object be fetchable on its own? So when I meant to say fetchable, you just need to relate it in terms of like our databases, like it should be referenced or it should be embedded. Okay, if it is a referenced object, it's usually in a separate table and it is in a new document by itself. And if it is an embedded object, it's an embedded object, they are usually in the same documents. So if you think that a particular object has to be called and referenced on its own a number of times, it's better that you have it in a separate document, so that you do not, like again, I think Matt was mentioning about atomicity of documents, right? You have some object which has to be referenced multiple times, then you will be blocking the rights for the entire document. So if that is fetchable on its own, just have it as a separate document. And then you have things like, will the data object experience growth beyond bounds? Typically, you're choosing NoSQL systems because this is one of the expectations. So this is where I take this example of a blog. So now let's say you have a doc type called blog with certain author, and let's say Couchbase wins as a title and whatever, and then you will have different threads for comments. Of course, comments can be in the same thread or it can be in the different threads. So blog is something that's just written once. That object is not going to be changed multiple times, but let's say that blog goes viral and people are commenting on it. That comments or the entities which is going to be changed often. So it just is more useful, or it's just better for us if we put the thread, that the child comment in a different document compared to the blog. So that's where the typical example of, okay, will the data object experience growth beyond bounds? Blog will not, but threads might. And are there a lot of concurrent writes and continuous updates? I think this also refers back to this example. If these are some circumstances that you can relate to when you're thinking about your objects and how you're designing them, then probably that's the one pointer for you to think about, okay, should I put it in a similar document or should I store it as a separate document? And this is just a follow up on that, if you have to drill down, then we come down to, okay, is it a one-to-one or one-to-many relationship? I think you can read this. If you have any questions, I'm happy to answer. If I take examples for each of these, we would use the entire 40 minutes. But this is some things that we believe, okay, of course there will be exceptions, but this has been the best practices which we propose. Okay, all this said and done, why is this data modeling still a manual process? Might be a question, and it is true. As of today, it is still a lot of it is, like when we talk to so many of our customers, what we learn is that, oh yeah, we have our own custom tools doing the modeling. Oh, we go back and forth and spend days doing modeling. And so why is it still a manual process? Going back to what I said, no enforced schema on write. So there is typically no reference point for modeling. Like for what we have been used to doing it for years now, like we always knew when we are migrating from one database to a target database, we identify, okay, how does that target database look? And then I'm going to modify my schema to match that target database. But now you have no reference point for modeling. And the data volumes are ever increasing. Access patterns change. So these are some of the characteristics why this typically has been a manual process. But we do realize that manual process is very tedious and it's inefficient, and it's also prone to errors because of the amount of time and the going back and forth without any process for validation. And that is where we understood the need for having some data modeling tool partnerships, which we wanted to leverage. We wanted to utilize the partners who are really good at doing this, because we believe data modeling is very crucial for your success with Couchbase. So we say that, okay, now we have some tools, data modeling tools, to typically do all the undifferentiated heavy lifting that we were talking about. But at the same time, we understand that you as an application owner or an application developer know your application the best. So we will also provide you the ability to customize your models and experiment and validate with it, but we will give you a framework which you can use and probably be more accurate in your modeling process. So now that I spoke about the data modeling integrations that we have, it's worthwhile to mention about our partners in crime for modeling. So we started off once we identified the crucial need for this, we started off with the partnership with Accolade in the March of 2017. And a lot of our customers have been using it, they've been giving us good reviews, and we realized that, okay, there's a very strong need. And now we extended this partnership with Erwin, who has been the leading data modeling provider for decades so now. So Erwin has introduced their new DM for NoSQL platform as their SaaS offering for their platform. And we definitely wanted to provide our customers the choice of having their most valuable partnerships. Like, you can use Accolade, you can use Erwin. These are probably the two popular names in the data modeling industry today, for at least for NoSQL, and you have the choice. And especially if you're coming in from like relational world, Erwin has been there for a long, so you might already be using Erwin DM. Now there's an opportunity to just extend it to NoSQL as well. So what are the typical use cases for using data modeling? One, first and foremost, migration from relational to NoSQL. Typically, you load the schema from RDBMS into your Erwin DM environment if you're already an Erwin user, and import these ER diagrams to DM NoSQL environment. And once you have, I think what exactly the transformation is will be more clear as I walk you through the demo. And once you've transformed these models, you can deploy them to Couchbase. New applications adopting NoSQL. Yes, irrespective of you being a user who is migrating from relational world or you're adopting NoSQL for the first time, data modeling is still very crucial. So if you're a new user who is like adopting NoSQL for the first time, you still need to understand your objects and lay out the basic physical schema for, okay, how does this access patterns be? What are the different objects which relate to one another? And then create these models ground up in DM NoSQL. And of course, we have the native integration with Couchbase, using which you can deploy to Couchbase. Okay. And another, so if you have this question that, okay, I'm not going to be migrating my databases every now and then, and I'm not going to be adopting NoSQL or making this decision on, okay, I want to choose this database is just a one-time activity. What do I do with this tool on an ongoing basis? So that's typically what we highlight in this section, where we say progressive iteration of models for performance optimization. So typically, the big data nature of applications is that we are expecting the volumes to grow over time. And I mentioned in my talk before that access patterns of applications and how the application data structure is oriented is the foundation for NoSQL data modeling. So when your applications are growing rapidly, you have the need to progressively iterate your data models for optimized performance. So typically you import, Okay, you import and there is a feature called reverse engineering, which I will touch upon when I'm demoing integration. So there is this feature where you can actually import and visualize the production data schema from Couchbase in Erwin environment. And then you can typically do the CRUD operations on it, like using the visual interface. Like you can create something, you can read it, you can delete it, do whatever you want. And then you can actually deploy it back to Couchbase. And once your production data is in Couchbase and you put the schema into Couchbase, you can actually query it using NiQL. And NiQL's query execution plan gives you actually a breakdown of how optimized your query is. Where exactly are your bottlenecks? What is how good are your indexes, etc. So what we typically suggest is import the data. You know that, okay, your application has gone viral and it has been growing beyond bounds. So typically just import it to Couchbase. Import the schema to Couchbase and then try to run the queries on using NiQL. And then you see, okay, your queries are really bad, then go back, remodel the database, and then remodel the schema for the database and repeat the process. So this also adds value for the validation process. Okay, so what are the biggest benefits that we want you to take away with this data modeling tool is that using this tool, data modeling, whether you do it manually or you do it using a tool, is very critical for your success with Couchbase and success with any database for that matter. So getting it right is going to be very crucial for you. and faster time to market, faster time to value, because you have this tool, you have the ability to validate, and a lot of those nuances of like what we mentioned before is done for you, where you can actually focus on customizing it and optimizing it and utilize your time better. So it's like faster time to value. And Erwin and Haculate both actually, they provide a good visual interface using which you can play around with these models, which you can tweak your models. You can see actually how your models look, import it to Couchbase and then say, oh, okay, this is how my models look now. Okay, now probably this is not what I want, and then I go up. Okay. And then the increased accuracy. Because you have this ability to validate, you can actually validate your models, which is a crucial factor for your success. Okay, so now I just have a quick demo. I have like 15 minutes, so we need to be quick in that, but I hope we can get through it. Okay, so this is typically your Erwin dashboard. As soon as you log into this site, you are prompted to this dashboard where you can actually discover your content, the data samples, and see what you typically have. In case you do not have, for pushing these samples, if you're an Erwin DM user already, you can push these data samples like this, your typical ER diagrams, directly from Erwin DM into this environment. And if you're not an Erwin DM user, that's okay. You just need your data to be in an XML format where you can upload. And you will have your data in this environment. So this is typically the place where you can just take a quick glance and say, okay, these are my relationships. This is a necessary prerequisite, as we call it. You either create them yourselves in this interface or you import it from some other tool. You basically need like what are the different relationships before you actually model it for the new database. Okay, so now you see that this model, I just imported it, is just seen here. Okay, so there are three things, there are three major features that Erwin DM offers if I have to summarize. One is the forward engineering. Forward engineering is all about taking these patterns that we are seeing, the entity relationship diagram, and converting it to the Couchbase compatible JSON models. And the second one is the transformation. So this tool provides you the ability to transform either as a normalized transformation or a denormalized transformation, or to do a custom transformation. And the final feature is about reverse engineering. That is, I touched upon it previously, that you can actually read the production data models from Couchbase into the Erwin environment and play around with it. We will actually take I'm hoping that we can cover all these three things quickly. So I'm using Couchbase, Erwin supports both, and I'm using publication data sample as our, let's say I do normalized transformation. Let's say I also do denormalized transformation. I see this is done. So you see that here those entity relationships were translated to JSON compatible models for Couchbase. So in this denormalized model, especially the way this tool is doing, that is Erwin's secret sauce on how they actually do this model. But typically how they do it is like after the analysis of your ER diagram, based upon certain best practices and rules that they have been adopting for years now, they try to embed certain objects versus reference certain objects. So I told you, like you want to embed your objects or you want to reference your objects is something that you as an application developer know it the best, depending upon, because you know your application and how it's growing the best. But based on the analysis of what you provided, we provide you a short of like, okay, certain objects, maybe it makes sense for them to be embedded versus certain objects, maybe you should reference it depending upon their use cases. I'll just show you quickly normalized transformation before I go into custom. So this normalized transformation is just for your convenience to see how those relationships were. This is completely deduplicated. NoSQL systems typically do not really rely on this, but it's just useful to get a mind mapping of like what the relationships were. Okay, so now let's do this custom transformation. So there are some best practices which is also laid out in line within the tool for you. So this is where I was saying that based upon our analysis and how we have been doing modeling for years, or like how Erwin has been doing modeling for years, they have certain objects laid out as, okay, I, for example, say book sales should be an embedded object. So, but you know it best, like, okay, your book sales should be, your object book sales should be an embedded object. Like, go back to the blog example that I gave. Should they be embedded? How are they going to get referenced? Are they related? And are they experiencing growth without bounds? You can use that as a basic pointers or rules of thumb and say, okay, I don't want this to be embedded. I just want this to be referenced because I think this is experiencing huge growth. And the same way you can say, like, you can use any other objects which we analyzed and we put it as embedded, but if you think otherwise, we provide you the flexibility that I mentioned before, and you will transform it. And here you go. You have this custom transformation where you see this book YTD sales is now a reference table. It was actually an embedded table, but because I made it reference, now it's a reference table. So you can always play around with this by cloning this model, and you can recreate each of these diagrams, but I'm going to skip this for the moment, skip that for the moment for the time. I still have one part which I have to go over. So how much time do I have? 10 minutes? Okay, probably quick. Okay, so let's see if I can. So I did mention about these models. So let's like quickly take an example of this deduplication publication model. I'm going to download it to my system. So now you see this downloaded, and okay, so yeah, before I proceed, I have the Couchbase instances running on AWS. I'm just trying to copy the downloaded schema onto Couchbase to show you how this embeds in Couchbase. So I'm just copying, I just copied the files that I downloaded in my local system to the EC2 instance that I'm running here. And now let me do. CD2, I don't know which path is that. Okay, so now I will take it. So I basically need to just I'm just making this an executable. And I need to set the path. And now we just run this. So this has a basic syntax, but I'm just using a different bucket name for you to identify it. Let's say I call the bucket demo. So now you can see that demo bucket is being created in Couchbase. Do you see this? Demo bucket was created in Couchbase. Now it is loaded with 70 items. And yeah, let's take a look at one of the documents to see what it looks like. So the models, the data models which you created, the JSON compatible models that you created have now been copied to Couchbase. So as you see, what it looks like is we are actually creating some junk data using these scripts. So what you will typically do is you as an application developer, you will take these models, you will take these scripts and you will embed the actual sample data. Okay, you will take the actual sample data and use it with your applications to create the models or to have your data modeled in the format which is compatible for Couchbase. So I'll just show you something quickly that once you have done this, you can actually run queries like this, and where you can see how, using the query execution plan, you can see, okay, how optimized your queries were. There is reverse engineering part. I really don't have time to run through that, so I'm sorry. But okay, do you have any questions for me real quick? I've run out of time, but I'm happy to take your question.
Hey, do you want the mic? Whoops. Probably got time for 2 or 3 questions.
Okay. Well, I'll try not to take all 3. I've been data modeling for a long time using Erwin. I won't say how long, but a very long time.
Oh, wow,
so
nice.
Yeah, so I'm very excited to see this, but I have 3 questions. So the first thing I want you to talk about, because it's so different from relational modeling, is your access patterns. You talked about that briefly, but can you give us a little bit more insight onto that? Because right now, relational data modeling, we don't have to deal with access patterns. That's the first thing. And the second thing, I believe you said the difference between modeling relational and modeling for JSON is that you combine not only the structures for the tables, but you combine the structures plus the data.
I think so. Yeah, we can revisit the slides and I'll be happy to.
Yeah, so the question I have about that is, then you're introducing an issue with data quality into the model. So how do you all deal with the data quality? Because so right now we don't have to so much deal. We need to deal with it, but it's not part of the actual issue in the data modeling process.
Yeah, I can definitely help with these questions. So first question which you asked was about access patterns. So typically when we say access patterns is like using set and get, which is like your key value store. It's like a key and then you have a value that is probably the fastest kind. It's like for cache use cases, it's the fastest kind of access that you have. So is that something that you want to define for that? That will be like how you'll be using that is like using the set operations or using the get operations. So is that what you want for your application is one. The second paradigm that I spoke to you about, where we focused a lot on, is that JSON. So if your models are typically if you want to store all your relational data, what you want to migrate, and it will be stored as JSON, you can convert it into this using JSON, and then you will use NoSQL. NoSQL is our other access pattern which works on, so just like how SQL worked on rows and columns, NoSQL works on JSON. Okay. But you can use your skills of SQL to do NoSQL. There is a huge overlap between how NoSQL and SQL works. And the third one was like how you can use other search indexes. I think this is a deeper conversation on like how you can actually lay out the access pattern.
Because I think you said the data when we're creating the JSON model objects is structure plus data. So you had an example with the last name and then you had the actual name.
Okay, so what exactly do you mean by data quality here? I just want to make sure.
Well,
I can go back to those slides.
My question would be, I was just saying that will introduce in the model, you need to actually have some type of data quality process completed.
Is this what you're relating to?
That,
okay.
That object all the way to the right I can't see the.
The
Right.
birth date, and this is this or like
Right, all the way to the right?
This
Yes,
one?
that.
Okay.
So you will have to have already had some type of data cleansing process done because it's one of those like last name, first name.
first name, last
Yeah,
name, and birth
yeah,
date?
you actually have the names here.
Okay.
But in the relational data model, we don't actually have the names.
I mean, that's okay. Like,
Yeah, but I'm just saying, that means we really need to make sure
think
that the data
so, sorry.
quality process has been.
I can talk to you
Okay,
right after
okay.
this. I'm
I beg
sorry
your
for
pardon,
cutting
really
you
didn't want
short.
to interrupt that very
But,
interesting
yeah.
conversation. We're now due for a break. It's 3:30.
I can
But
talk
think
to you
you'll-
after
Yeah,
that.
feel free to. If you do have any other questions, we'll barricade the doors and we'll not let you leave. That's basically the plan. But if anyone wants to part, so. Should say thank you very much for attending. This is the last session on this track in this room, so thanks very much for attending. I do have a 30-minute break now, and then we're back into the main ballroom, the one that we were in this morning, for the excitement of a live demo and a panel discussion. So 30-minute break,
sure.
and then 4 p.m. back in the ballroom. But do hang around if you have any other questions. Thank you.
Thank you so much for taking time, and I hope this was useful.